everyone, welcome back to the class. In our last class, I explained the concept of negative exponent of base. And in that class, we saw a few examples based on negative integral exponents. In today's class, we will be solving a few more numericals or few more exercises based on negative integral exponents. And our idea will be more clear than before. So let's proceed one by one. The first example is about addition of three rational numbers with negative exponents. So the first term is half, then raised to the power negative 2 or minus 2. Then with that we are adding 1/3 raised to the power minus 2 or negative 2. And then with that we are adding one more term, and that is 1/4 raised to the power negative 2. So how we can solve this? Now we know, we have learned that one of the properties that a to the power minus n or negative n, where a is the base and n is the minus n is the negative integral exponent. This can be written as 1 upon a raised to the power plus n. So if we go by that property, then this can be, the first term can be written as 1 upon, then here it will be half, then raised to the power n, means here it will be 2 simply. And then the next term, it will be written as 1 then upon 1/3, and then the power is, it was minus 2, so here it will be plus 2. Then we will be adding the third term, and this time it will be 1 upon, then it will be 1/4 to the power plus 2. We know another property of exponents. Suppose if a and b two integers and it is expressed as a ratio of two integers, means if it is a rational number, then, and if we have an exponent of that rational number, then it can be written as a to the power n upon b to the power n. So this can be separately expressed. The numerator and denominator will have the same exponent, and then that can be expressed as a ratio of those two terms. Now if we go by this property that I have written here as second, then it can be further written as this half to the power n. That means a by b to the power n. It fits with this format. So it can be further written as 1 to the power 2 and then 2 to the power 2. Then similar concept can be, a similar property can be applied to the second term and third term as well, and it can be written this way. So it will be 1 upon, then it will be 1 square, then it will be 4 square or 4 to the power plus 2 or positive 2. Now what we will do next? Here it is 1 divided by 1 square and then by 2 square. So if we think this as a division of two rational numbers, then first rational number if we take as 1, so what we will do, we know as per the rule of division, then it can be written further as multiplication of the multiplicative inverse or reciprocal of the second rational number. That means if this is the second rational number, then multiplicative inverse will be, or reciprocal will be 2 square divided by 1 square, and this time it will be multiplied instead of division. Now then we will add the second term, and this time we will be applying the same concept. Here it will be taken as the first rational number, then we will multiply the multiplicative inverse of the second rational number, then we will add the third term here. So it will be 1 multiplied by, then it will be 4 square divided by 1 square. Now further what we can write, 1 means 1, 2 square means 4, 4 divided by 1 square means it will be 4 only. And so we can write this way, 1 multiplied by 4, then plus, then it will be 1 multiplied by 9, because here 3 square will give us 9, divided by, here it will, in the denominator we will have 1, and then 1 multiplied by, it will be 16 divided by 1, that means it will be 16 only. So here it will be 1 multiplied by 16, that means we will get 4 plus 9 plus 16, so 16 plus 4 20, and then plus 9 it will be 29. So this is the answer of this expression. Now we'll move on to the next exercise. It says that it is 3 to the power negative 1, then that is multiplied with 4 raised to the power negative 1, and then the result of this multiplication again has this negative exponent, which is minus 1, and then with that we are multiplying another term, which is 5 raised to the power negative 1. So how we can simplify this, and let's see what will be our simplified answer. So here it is, again it will follow this property, a raised to the power negative n, it will be 1 upon a raised to the power positive n. So it is 3 to the power minus 1, so it will be simply 1 upon 3 to the power plus 1, and then multiplied by, it will be 1 upon 4 raised to the power plus 1, and then that multiplication, result of that multiplication will have this exponent. So we will simplify in next step that, and then it is 5 to the power minus 1, so it can be written as 1 upon 5 to the power plus 1. Now let's see what we will have next. 1/3, and it will be 1/4. So 1 by 3 multiplied by 1 by 4, so finally it will be 1 upon 12, and then we will have this 1 by 12, this rational number will have this negative exponent minus 1, and then it will be 1 divided by 5. Now again it is a to the power minus n, so it will be 1 upon, then 1 by 12, and then it will be plus 1, then 1 by 5. So further it can be written as the example we have seen in the previous case. So it will be, this 12 will go to the numerator. So it will be 12, 1 multiplied by 12, and then it will, in the denominator we will have 1 to the power 1. So simply it will be 12 only, and then we will have in the second term it is 1 by 5. So simply it is 12 and then multiplied by 1 by 5. So it will be finally 12 by 5 only. So it will be 12 upon 5, and this is the answer of this expression. Now let's see what is waiting for us next. The next expression we have this 1/3 to the power again negative exponent. So this time it is negative 3. Then from that term we are subtracting another term where again that rational number has negative exponent. Here it is again negative 3 or minus 3, and this whole result of subtraction is divided by another term where we have a base, a rational number as base, and that base has a negative integral exponent. So let's simplify this. So again it has this property, a to the power minus n will be 1 upon a to the power plus n. So if we write this further, then it will be 1 upon, then 1/3 to the power 3, and then from that we will be subtracting the next term. So it will be, the next term will be written as 1 upon, then it will be half to the power 3, and then from this result of subtraction that will be divided by, here again we have another term with negative exponent, so it will be written as 1 upon 1 by 4 to the power 3. So it will be again 1 to the power 3, so it's 1 only we know, and 3 to the power 3. So it will be 3 to the power 3 means 3 will be multiplied 3 times by the same number, so it will be 27. Then 2 means it will be 8, 2, 2, 2, so it is 8. And 4 means 4 to the power 3 means 4 will be multiplied 3 times by the same number, and it will be 16, 4 is 64. So here since this 3q will go to the numerator that we have seen in previous cases also, so it will be finally 27. then minus this 2q will go to the numerator, so it will be 8, and this is the result of subtraction, and that will be divided by this 4 will go to the again numerator, and that is 64, as we have seen already. Now from 27, if we subtract 8, then what it will give us? It will give us 19, and then that will be divided by 64. So simple, it will be simply 19 divided by 64 only. So this is the answer of this expression with negative integral exponent. So it's easy if we have the good concept of the properties and of this negative integral exponent, then it's easy to simplify any kind of expressions or complex expression. Now let's move on to the next exercise. What it says that by what number should this half to the power minus 1 be multiplied so that the product will be minus 4 by 7 to the power minus. So let's assume that x should be multiplied with this number, where half to the power minus 1, and then the result of that multiplication, as it is given in the problem statement, is minus 4 by 7 to the power minus 1. So it looks simple. So here it will be x, and then multiplied by, it will be 1 upon half to the power 1, and then that result will be 1 upon minus 4 by 7 to the power 1. Okay, now x, then this 2 will go to the numerator, so it will be 2, and here this 7 will go to the numerator, so it will be minus 7 by 4, right? So from here, if now we want to know the value of x, it will be simply minus 7 by 4, and in this equation, if 2 changes side, then here it is multiplication, so when it will go to the other side, it will be division. So we will divide this term by 2. That means we will multiply it by 1 by 2. So it will be finally minus 7 divided by 8. That means we will multiply this number by minus 7 by 8 to get this value, minus 4 by 7 to the power minus 1. Now let's see what is waiting for us next. The next problem says that by what number should this minus 15 to the power minus 1 be divided so that the quotient may be equal to minus 5 to the power minus 1. So again, let's assume that that number is x. So by what number should this given number be divided? So minus 15 to the power minus 1, if it is divided by x, as we have assumed, then that result of that division will be or may be minus 5 to the power minus 1. Now minus 15 to the power minus 1 means 1 divided by minus 15 to the power plus 1. Again the same property, this, right? So it will be 1 upon minus 15 to the power 1, and then that number we are dividing by x, and we are getting this result. So this time it will be again written as 1 upon minus 5 to the power 1. Let's do this way, that x, since it is divided, x is dividing this number. So if suppose if we take x to the other side of that equation, so it will be 1 upon minus 15, and then to the power 1 means it will be minus 15 only. Then x will write to the other side, it will be taken to the other side, and then this factor can be written as minus 1 divided by 5, as it is minus 5 to the power 1 minus 5. Why I have taken x to the other side? Because x is here we have in the denominator, and we want to find the value of x. So it will be easier for us if we take x to the other side. Then x, if we will keep, and then what we will do, we will 1 by minus 15 we have this side, and we will divide this term by this term, or this value, this rational number. So it will be x, when we will find out, it will be simply this value divided by this value, as if it is a is equal to x into v. So x will be a by b. or a divided by b. So it will be 1 by minus 15 and 1 by minus 1 by 5. So how it will be written? Minus 1 by 15, and since we are dividing, so we will be multiplying by the multiplicative inverse. So it will be minus 5. Since it is 1 by 5 or minus 1 by 5, so it will be minus 5 only when we will multiply. Now minus 1 minus 5 means 5 multiplied by minus 1, and when minus 1 and this minus 1 will be multiplied, so it will give plus 1. This simple concept we know. And this 5 and this 15 has a common factor 5, so 5 and this 5 will cancel each other, so here we will have 3 only in the denominator. So finally the answer will be minus 1. Here it will be minus 1, so minus 1 it will be plus 1 and divided by 3. So this is the answer. That means this number minus 15 to the power minus 1 should be divided by 1/3 to get this value minus 5 to the power minus 1. So I hope you have understood very well the concept of negative integral exponents, because we have solved many examples, many exercises based on that, and in future you will be able to simplify any kind of expression. So with this I end today's class. Thank you.